I am Anil Kumar sharing with you an excellent variety of trigonometric functions derivatives. These are application questions based on derivatives of trigonometric functions. Question number 1 is determine the absolute extreme values for y equals to 3 sine x plus cos x, where x is in the closed interval of 0 to 2 pi. So you have to find absolute extrema. Question number 2 is find slope of tangent line to y equals to tan cosecant x when sin x is equal to 1 over pi x in the interval 0 to pi by 2. So now we'll find slope of tangent line for a function which is tan cosecant x. Question number 3 is determine the concavity. So this is second derivative. Determine the concavity of the graph of the function y equals to secant x plus tan x in the interval minus pi by 2, pi by 2. And the last question here is, an isosceles triangle is inscribed in a circle of radius r. Find the value of x that maximizes the area of the triangle inscribed. So we're talking about inscribed triangle within circle of radius r. So this angle given to us is 2x. We have to find what x is. You can actually copy these questions, solve them, and then look into my solutions. Most of these questions are from previous test papers, and so I hope that the students who are taking IB and AP calculus will really help from these examples. So let's do question number 1 first, which is determine the absolute extreme values for y equals to 3 sine x plus 4 cos x, where x is between 0 to 2 pi. To find absolute extrema, we have to find the value of the function at 0, at 2 pi, and at critical points. So let's first find the critical number, right? So here we have to find the critical number, which is that the derivative is equal to 0 or it does not exist, correct? That's the whole criteria. So let's find the derivative first. So derivative of this function is 3 times cos x. Now cos x derivative is negative sine x, so I'm writing negative first, 4 sine x, correct? Now for critical number, this should be equal to 0. So we have 3 times cos x minus 4 sine x equals to 0. Now we can take 4 sine x on the other side. So we get 4 sine x equals to 3 cos x. Now we can divide by cos x and take the numbers on the right side. So we get sin x over cos x equals to 3 over 4. Sin x over cos x is tan x equals to 3 over 4, and that gives you your critical numbers. So when I say that tan x is 3 by 4, that means we are looking for two values within the domain 0 to 2 pi, right? So we're looking for what? We're looking for positive values of tan, which are in quadrant 1 and in quadrant 3. So the idea here is to find the related acute angle first. Since we have a positive value, that will also be one of the solutions, right? So we can calculate what is x equals to. X should be equals to tan inverse of 3 over 4. Since we are doing it in radians, I have to get the answer in radians. So let me get the calculator. We'll now calculate the value. Tan inverse 3 over 4. So let's put the mode in radians, which is option 4 in this calculator, and shift tan inverse 3 divided by 4 is equal to 0.6435, right? So that much in radians. So we get one answer. The other answer is pi plus that. So the other one is, so we say x is also equal to pi plus 0.6435. So let me add pi to this now. So add shift pi, which is equal to 3.785. 3.785. I can write this as 1, right? So these are the two critical numbers in our case. We have to find absolute maximum or minimum. That is to say, we'll find the value of the function when x is equal to 0. So that is one value. When x is equals to 0, what is y equals to? So y is equal to, if I write 0 here, sine 0 is 0, cos 0 is 1. So we get 3 times 0 plus 4 times 1. That gives me a value of 4. If I write 2 pi, in that case, x equals to 2 pi means y equals to, for 2 pi sine x is 0 again, right? And for 2 pi cos x is again 1, so we again get 4. So this is 4 for both the values. Let us now calculate the value for these two critical numbers, 0.6435. What is y equals to? So let us use the calculator to find this value. So we have 3 sine 0.6435 plus 4 cos 0.6435, right? So 3 times sine 0.6435 plus 4 times cos 0.6435 is equal to, we get the value as 5. So 5 is definitely much higher than those numbers. So we get probably our maximum. And the other value here is 3.7851. So for this, y is equals to 3 times sine of 3.7851 plus 4 times cos of 3.7851, correct? So this value is, let's change the value. Okay, so we have 3 times sine of 3.7851 and cos of 3.7851 equals to, we get minus 5 for this value. So that becomes the absolute minimum, correct? So we have absolute maximum at 0.6435 and the value is 5. And we get absolute minimum at 3.7851 and the value is minus 5. Is that clear, right? So that is how you should be doing such questions based on absolute maximum and minimum. Now here is the second question. We need to find slope of tangent line to y equals to tan cosecant x when sin x is given to us and x is in the interval of 0 to pi by 2. So what you should know here is that derivative of tan x is secant square x. So let me write down here d dx of tan, let's say theta, equals to secant square theta. And then you need derivative of cosecant theta also. Let me write d dx of, I should write x only since I have no d dx. So derivative of cosecant x is equal to minus cosecant x times cot x. Is it okay? So that you should know. Now here, one more important thing is sin x is equals to 1 over pi. What does that mean and how can that help us? Basically, we are looking at a triangle here where if this is the angle x, sin x is 1 over pi. That means opposite over hypotenuse is this value, correct? So the adjacent side will be square root of pi square minus 1 square root. Perfect. So this is what it means. So that's the meaning of this thing, correct? Sin x is positive, 0 to pi by 2, quadrant 1 we are talking about. So in quadrant 1, all are positive. Okay, so I hope that's a good hint. You can now pause the video, answer this question, and then check with my solution. Okay, so let's find slope of tangent line. We are given y equals to tan of cosecant x. So dy dx is equal to derivative of this. Derivative of tan theta is secant square theta, which is cosecant x, right? Times derivative of the inside function, which is cosecant x. Perfect. So that is a very important step. And now what we get here is secant square cosecant x times, now derivative of cosecant x is negative cosecant x cotangent x. Perfect. That's what you get. And since you have to find slope of tangent line when sin x equals to 1 over pi, that means if sin x is 1 over pi, then what is secant square x, right? You have to check this out. What is cosecant x? That you have to write down. All these values you have to fill in, correct? So let's find these values one by one. Let's begin by cosecant x. Now you can see here, cosecant x is reciprocal of sin x. Simple. So that is pi for us. Is it okay? So this is pi for us. Now, what is cotangent x? Now, cot x is adjacent over opposite side, which is square root of pi square minus 1 divided by 1, correct? Is that clear to you? So that is cot x. So now let's substitute these values. So we are substituting the values when sin x is equals to 1 over pi. In that case, the derivative dy dx, which is the slope of the tangent line, is secant square. So cosecant x is pi. So we'll replace this with pi times minus, this is pi, and cotangent x is square root of pi square minus 1. Is that clear to you? Correct? Now what is secant pi? Secant pi is secant square x. Secant square of pi is just 1, right? So this is 1 for us times minus pi square root of pi square minus 1. Or we can say that the slope m is equal to negative pi square root of pi square minus 1, correct? So that becomes the solution for us in the given condition. Is that clear to you? So this is a very interesting question. You need to understand the condition given, sin x equals to 1 over pi. That helps you to find all these values. So I hope you find it very interesting. Now let's move on to the next question. Now here is question number 3. Determine the concavity of the graph of the function y equals to secant x plus tan x in the interval minus pi by 2 to pi by 2. I'd like you to pause the video, answer this question, and then look into my suggestions. Now, what you really need here is to know the derivative of secant x and tan x. Let me write them down here. So we have d dx of secant x as equal to secant x tan x. Slowly you have to remember all this, correct? d dx of tan x is secant square x. Also, what you need to understand is this interval. When we say interval is between minus pi by 2 to plus pi by 2, it means what? This is minus pi by 2. Do you see that? And that is plus pi by 2. So we are talking about quadrant 1 and 4. Is that clear? Okay. Now the term concavity. Concavity means we are looking for second derivative. Perfect. So concavity means second derivative. So I hope now the question is absolutely clear. You can still solve it and then look into my suggestions. So the function given to us is y equals to secant x plus tan x. Now let's find the derivative. Dy dx is equal to derivative of secant x is secant x tan x, and derivative of tan x is secant square x. Second derivative, that is d2y dx square, is what? So we can apply the product rule. That means we'll do d dx of secant x times tan x plus secant x times d dx of tan x. So that is the first term plus derivative of secant square x. Clear? Derivative of secant x is product of secant x and tan x. Then we have times tan x plus secant x times tan x derivative is secant square x plus secant square x. We'll apply the product rule, power rule, 2 times secant x times derivative of secant x, which is secant x tan x. Is that clear? Now, we have these 3 terms and secant x is common in all the 3. So let's take it out. We're left with tan square x. Here we get secant square x. And here we get 2 secant x tan x. Now this term is a perfect square. So I could write this as secant x times tan x plus secant x whole square. Perfect. Now you can see that at this stage this is a square, so it is always positive. How about secant x? If you're looking at quadrant 1 and in quadrant 4, secant is also positive, right? In quadrant 1 and in 4. In 1 all are positive, his cosine is positive. So that means that the second derivative is indeed greater than 0. Second derivative means greater than 0 means the function is concave up, correct? That's what we wanted to prove, concave up. So if the second derivative is positive, the curve of the graph has to be concave up in the given interval. Perfect. So that is how we can prove it. So I hope it's absolutely clear. Very important question. Now let's move on to the last question of this derivatives of trigonometric functions. The last question here is, an isosceles triangle is inscribed in a circle of radius r. Find the value of x that maximizes the area of the triangle. So we have already drawn a triangle, isosceles. Let's say these two are equal size. To find the area, I have to draw a perpendicular from here, right? So that's the perpendicular. Let us say the triangle is ABC. Okay, touching the circle like this. In that case, if this is my center of the circle, if I draw this line, then that should be radius r. Perfect. Okay. And the side given to us is 2x. That is the side 2x. So if you see this particular triangle, in that case, what we can write about the angles. Now, let us assume I wrote 2x there. Let me take the side, this angle, because these two angles are equal, correct? These two angles are equal. So since I would like to take this as my base, right? So area of triangle, let me write down here. Area of triangle ABC is half of BC, the base, times A to, let's say, M, okay, AM, right, times AM. Now we know this side is R, means this is also R, correct? Radius, this is also R, right? Let's say this is R, both are R. This is also R for that matter. This is also R, okay. But the height AM is R plus, let's say this height from O to M. We have to get that side. How do we get that portion? So what I will do here is I will take this angle as theta, let us say. Okay, so we'll work with this angle theta, and since it is an isosceles triangle, we can work what 2x is. Is that clear to you, right? Now, this angle theta means the total angle here will be 2 theta. Perfect? Okay. Now, we'll write all this in terms of theta. So what is BM equals to? BM will be R cos theta, right? So we could now write this area of triangle ABC as equal to half of BM is R cos theta, right? So R cos theta, and that is also same because these two sides will be equal. It's an isosceles triangle. If I drop a perpendicular, it will bisect. So it is 2 times R cos theta plus R cos theta, that means times 2, right? So that becomes the base times height, which is R plus R sin theta. Does make sense, right? I hope that is clear to you. So that becomes the area of triangle. Now to find maximum area, we'll take derivative of this area, right? So derivative of this area will be, let's simplify this expression also. 2 and 2 will cancel. So, and we can take R common. So before taking derivative, let me simplify this. So we have R square cos theta times 1 plus sin theta. Correct? So I hope this is clear to you, right? Okay. So from now, we can actually apply the product rule on this and get the derivative. So now let's find the derivative d dx of this area. Let me write this as capital A, right? Or capital A. So the derivative of area is R square is constant. Let's keep it outside. Okay. Now we'll apply the product rule. Derivative of cos theta is minus sin theta times 1 plus sin theta. And then we'll do plus cos theta times derivative of sin theta, which is cos theta. Correct? So that's what we get. Now let's expand it. So if I expand it, I get minus sin theta, and here we get minus sin square theta plus cos square theta. Correct? So we get all this. Now we can get a quadratic equation in sine by writing cos square theta as 1 minus sin square theta, right? So we'll do that. So we could write this as r square, and this is minus sine theta minus sine square theta, and cos square theta I am writing as 1 minus sine square theta, right? So I'll write this as 1 minus sine square theta. Is it okay? So that gives you r square times 1 minus sine theta, and here we get minus 2 sine square theta. So for the critical number, this should be equal to 0, right? So for critical number, r cannot be 0. That should be 0, right? So for critical number, that should be equal to 0. So this really means that this whole thing should be equal to 0. That is 1 minus sine theta minus 2 sine square theta should be equal to 0, right? So we have to solve this quadratic equation. Let me write this as, we'll take it all to the right side, multiply by negative. So we get 2 sine square theta plus sine theta minus 1 equals to 0. Perfect. Now we can actually factor this equation. So if I factor, I could write sine theta as 2 sine theta minus sine theta. So I get here 2 sine square theta. I'm writing this as plus 2 sine theta minus sine theta minus 1 equals to 0. We can take common factor 2 sine theta here. We get sine theta plus 1 minus sine theta plus 1 equals to 0. That means sine theta plus 1 is a common factor, and 2 sine theta minus 1 is the other factor. So that gives you sine theta equals to minus 1 or sine theta equals to half, correct? So these are the two values for theta. Perfect. Now, if you look into this triangle, the value of theta is between, it's just half of it, right? So 2 theta, from this triangle, maximum 2 theta, let me write down here, what are our boundary conditions? Let's try to understand that. So this total is 2 theta, they are equal, right? So 2 theta has to be greater than equal to 0 and less than equals to 2 pi, correct? So we can never get the negative value. So in this particular case, it is not valid. The only valid answer is sine theta equals to half, which is for a triangle, as you know, half is 1 to square root 3 when we're talking about pi by 6, correct? So that means theta equals to pi by 6. So this theta is pi by 6. Is it okay? So 2 theta will be pi by 3. So 2 theta will be equals to pi by 3. So we have pi by 3 here, pi by here. What should be 2x equals to? Well, pi by 3, total is pi, and that implies that 2x is equals to pi by 3 also. Is it okay? So 2x is pi by 3. We need to find the value of x. That means x is equals to pi by 6. Do you see that? Since 2x is pi by 3, x is pi by 6 for the maximum area. Is that true? Perfect, right? So that is how you can show that this is the maximum area. For maximum area, the angle is an equilateral triangle. In fact, all are 60 degrees. Is it okay? Or pi by 3. Now, we did find that the critical number gives us this value. How do we know that this value is indeed the maximum value? Now, we can always find that out by using the extreme values 0 and 2 pi, correct? So to show that this is indeed maximum, so theta is pi by 6, okay? Theta is pi by 6. So that is a critical number. So we'll find the value of the function for, so area, we'll find the area when theta is 0 for us, right? Since this we are writing in terms of theta, that means we have, when I write 0 here, sine 0 is 0, we are left with cos 0, which is 1, so we get r square, and which is also equals to the angle pi. So if I write pi here, so sine pi is 0, cos pi is minus 1, so we have to take absolute value, of course, when we are talking about area. So it is again r square, right? So that is same as r square. Now, for pi by 6, what is the value? Let's calculate this out. So we have cos pi by 6, cos of pi by 6. Let me first check if I have the mode in radians, 4. So let's calculate. So cos of pi by 6, pi by 6 is right there. So pi divided by 6, cos of pi by 6 times 1 plus sine of pi by 6, sine of pi divided by 6 is equal to, we get in decimals 1.29, right? So it is 1.3 times r square. So the area for pi by 6 is 1.3 times r square. So which is indeed greater than r squared. Do you see that? So that is why it is the maximum area. Perfect. So we say, since we take the total angle as 2x, x is pi by 6. Perfect. Let us go through these steps once again in question number 4, when we want to prove that the inscribed triangle has maximum area. We are trying to find the first derivative, critical points. Critical point was for theta equals to pi by 6 or 2 theta equals to pi by 3. So find the values of the area r square cos theta 1 plus sine theta for theta equals to 0, 2 pi. So theta should be equal to half of 0 is this and pi, correct? So the value of theta should be tested at extreme values for theta, which are 0 and pi, and the critical number, which is pi by 6. So for 0, we know sine theta will be 0, sine 0 will be 0, cos 0 will be 1, so we get r square. For pi, we get minus, but area always should be taken as positive. For pi by 6, we get 1.3 r square, which is the maximum value. Perfect. Therefore, an equilateral triangle with the angle of pi by 3, total angle, half will be pi by 6, is the one which gives you the maximum area. So I hope in this series, the 3-4 examples which we have taken, this one based on optimization. Before this, we took an example for concavity, second derivative analysis, and then we found the tangent for a given value of sine of x. That was very interesting. And the derivative of the function. I hope you appreciate and understand these examples. They are definitely going to help you a lot in your test. Feel free to write your comments, share your views, and if you like and subscribe my videos, that'd be great. Thank you and all the best.